Regents exam, Algebra 1, August 2016, problem number 27. Consider the pattern of squares shown below. Which type of model, linear or exponential, should be used to determine how many squares are in the nth pattern? Explain your answer. In this problem, we are provided with a series of squares that follow a predictable pattern. We need to determine the type of model, either linear or exponential, that can be used to predict the number of squares in the next iteration. We also need to explain our answer. We can determine the answer to this question by analyzing the pattern of squares. The first iteration of this pattern contains 2 squares. The second iteration contains 4 squares, and the third iteration contains 8 squares. We can determine the type of model this pattern follows by calculating the difference between successive iterations. From the first to the second iteration, 2 additional squares were added. From the second to the third iteration, 4 additional squares were added. If this pattern were to follow a linear model, then we should be adding a consistent number of squares. In this case, we should be adding 2 squares per iteration. At this rate, the third iteration should have a total of 6 squares and not 8. Since the pattern does not increase at a constant rate, we cannot use a linear model to determine the nth pattern. With that said, we can conclude that the pattern follows an exponential model, particularly 2 raised to the power of n, where n is a positive integer greater than 0. When n equals 1, we have 2 raised to the power of 1, which simplifies to 2. When n equals 2, we have 2 raised to the power of 2, which simplifies to 4. And when n equals 3, we have 2 raised to the power of 3, which simplifies to 8. So an exponential model is a perfect match since the pattern does not increase at a constant rate. So this is our final answer.